All right. Hi everyone. Hello. So assignments largely submitted. Should be, right? So for the ones that haven't noticed, the assignment system or submission system is or was up, is still up in fact. So if you haven't continued to submit there or attempt to submit at least, then we'll debug from there, I guess. Please do that with as soon as possible, so we kind of wrap up that chapter, that particular assignment. We can turn to other things. If you want to see whatever I'm showing here, please start the screens. Right. Apart from the assignment, there was some other point I want to remind you of, and that is the student barometer. Right, so I think every Norwegian student in the second year gets a inquiry to participate in the student barometer. Well, something like that. You should have gotten emails. In fact, heaps of emails regarding that. Yes, and I suspect those have been possibly neglected based on assignments and deadlines and other obligations that you might have had. But I should explicitly encourage you to participate and actually give a realistic assessment of what you're actually doing, because it's important to identify the workload you're actually having and in how far it corresponds or does not correspond to the workload we think you're having. You know what I mean? So it's quite important for planning for us and also in other universities. Note that the department or the student body that participates most will be in for a draw, I believe, of some iPads or something like that. So there's a certain incentive for you to collectively participate as much as possible, so you actually get something out of it. But you definitely get something out of it, because you probably get we get a better understanding of you guys, what you guys are up to, and yeah, kind of as an indirect input into our teaching, right? So please also stream, please participate in the student barometer. I think when is the deadline? Okay, no one has opened the email yet. Okay, that's good. Oh, one of the many. Yes, I understand the concern, because it's not like on the top of your priority list, because you have other things to do and you don't get marks for it and all that kind of stuff. But please consider or please respond to the barometer. So it'd be good. Yeah. Is anyone unclear what I'm talking about here at all? Everybody knows that student barometer, right? So you should have gotten emails, as far as I know, heaps of them in fact. Good. So cool. So that was part number one. So it's important to cover that aspect. Going from here, another administrative aspect is the group allocations. So we asked you to submit your preferred group allocations until last Friday, right? So, and I believe 23 people did so. That's good. But for the remainder, we have basically assigned you to, random groups, and it's indeed random. So you will see what you get, and I'll basically attach the results of this allocation to the third assignment. So there are two attached files, and you can look you up yourself by name, and you'll find the group you're a member of. But sometimes may also be confusing, so I also added a setup that is organized by a group, so you can actually see the group allocations more clearly. So it's two PDF files. Please identify your groups. For the ones that have been, not really creative in defining their own group name, I found the group name group particularly creative. So at least it was lowercase, so we're happy with this. That was all we expected. So so it's good. So we hardly had any semantic ambiguities. So most people stuck to the conventions that we suggested. But so for the rest, I kind of came up with even more creative group names, A, B, C, D, and so on. You can obviously substitute for something more meaningful, but the allocation is now there. So please find you and your group members as part in that list, and organize yourself so you can actually work on assignment 3. Again, assignment 3 is group based and builds on assignment 2, right? So you probably need to or should reuse code that you have been working on. But the challenge is, obviously, if you have 3 people, you have 3 code bases. Well, hopefully, for the ones that have submitted anyway. But so you need to select the code base you want to be working off, right? So it doesn't imply that you need to maintain and work off all the 3 solutions that you guys have developed for assignment 2, but pick one of them and go with that one. So it's a good way for you also see it as an opportunity to actually do code review, right? So to look at each other's code randomly, because your assignment is largely randomly, apart from the people that have self-assigned. But I think it's a great opportunity for you to go through code and think about, okay, which one is the easier code base to work from, especially if you're the uninvolved one. This is good for the person who wrote the code, but also for everyone else to see what characteristics of code are suddenly important, right? So as opposed to just getting your work done, just meeting the functional requirements. So so there's something good in there as well, I guess. If you don't find yourself in the list, or if you are mistakenly amongst the ones that are randomly assigned, but you actually have been previously assigned elsewhere, please let me know, so I'll fix that. But other than that, please work off that list and find your group members to start working on assignment 3 eventually. But good. So that's the 2 main administrative messages I want to get across. Any questions regarding this? I take that as a no. So, right. Okay. Cool. Right. So for the 3rd assignment, we have 2 essential challenges. 2 new things that we're dealing with are a chatbot, which we're not talking about yet. I think Marge intends to post a video on that one. And the other thing is Docker, or containerization in a wider sense, because it's something that's increasingly relevant and I think will come back to you over your professional career, even if you're not working in the cloud area at all. So anyone who didn't take the cloud course, they actually will still probably be exposed to Docker eventually and need to deal with this. So it's a good opportunity for you guys to explore that a bit. And we'll start doing that today. But before we get to that, there were some inquiries regarding the understanding of OpenStack. So in the last session, I may have been a bit too fast, I guess, going over the essential features. So I wanted to highlight it again, but also I think you have had other things on your mind, so it may not be your first priority to actually play with Docker. So with OpenStack. Who actually logged on and played with this? Yep, 2, 3. Anyone else? A bit? Yeah? Okay. Okay. So who logged on and didn't play with it? Okay. All right. Okay. So it's actually not a stupid question. Okay. All right. Fair enough. Cool. So no, that's all right. In fact, because it was not relevant for the current assignment, so we didn't really require you to deal with this to a great extent. But for the next iteration, or for particular for getting more comfortable with Docker, I think it's quite worthwhile also looking at OpenStack, at least understanding the key differences here. So again, so who feels comfortable in this environment right now, or still recalls what I talked about, and who wants me to run through some essential elements again?
Take one question at a time.
Yes.
Raise hands.
Yeah. So that's why that's a good moderation. Yes. So number 1, who is comfortable? Run. Okay. Cool. So who wants me to go through all the details, or some, right? So I'll give a brief overview again. Again, we contrasted, this is a infrastructure as a service solution, right? So it's quite in contrast to a platform as a service solution, right? So where we're actually dealing with a supported set, let's say, of programming languages or application development platforms, but you actually don't deal with the underlying infrastructure, right? So you hardly deal with networking. In fact, you do deal with a bit of networking. So what networking aspects did you guys need to consider for Heroku? What was the only networking aspect you guys needed to consider when implementing? Yep, let me see.
We need to get our port from Heroku.
That's right. So Heroku defines the port allocation. So you actually need to interact with this to some extent, but that's as far as it goes, right? Secondly, you have moderate control about CPU there. In fact, not really. You can suggest that your web application should be scalable, for example, right? So we didn't really exploit that at all because we don't really put load on it. But this was one of the characteristics, but you can only go as far as to say, well, you know, there's a certain scaling element that you want to consider, but it's not really explicit. You don't know how much RAM you actually use and things like that. So in the infrastructure as a service sphere, that's quite different. So in fact, you're dealing with all those things: networking, storage, and computing. Those are the three core elements. And one is implicit anyway, is authentication, obviously, right? But that's the same for PaaS platforms as well. So, and this is the key idea. So basically, when we looking at OpenStack, for example, as one alternative to AWS, so that's the kind of the simpler take on it, is basically a collection of open source tools that have developed solutions to manage CPU, RAM, storage, and networking capability in kind of in a virtual environment. And OpenStack has integrated all those different approaches into a kind of coherent system that is very similar to Amazon's AWS's EC2, right, which is their virtual machine platform, which you can run. And the patterns you find here are fairly similar. So it's merely about providing a runtime platform for your virtual machine, for your instance, right? So, and the instance here means a complete machine, including operating system, you know, input, output, possible user interfaces, and so on. So you actually manage your full operating system from bottom up, yeah? Infrastructure as a service. And key things in those systems is that you are allocated a set of resources, and the allocation of resources is generally across instances. So it's not like you get, oh yeah, you get 5 CPUs or 5 machines that have, you know, 4 cores and 4 gig of RAM each and 40 gig of or 80 gig of hard drive each. But rather than that, you actually get a number of virtual CPUs allocated, RAM that you can use at your discretion, IPs, and volumes, so and storage that you can use. So, for example, in this particular account, I can instantiate up to 5 instances. I have a maximum of 5 CPUs. So if we want to exploit, for example, my instances and run 5 of them, I can only have 1 CPU each, right? If I, for example, only run 2 instances, I can give them, you know, 2 CPUs each, for example. And the same for RAM and storage as well, right? So you can freely allocate and shuffle around. So it's a bit of an opportunity of planning. So on this level, you already have a dissociation of machine and resources, right? All the available resources. And in OpenStack, in this overview, you basically see where your limits are. So it's quite important if you do capacity planning, you need to look at the bigger picture, look at the individual machines you need, and aggregate the resources you overall need. Yeah, so it's quite important to know relatively precisely what machine configurations you will be running, because when you request for resources, that's the way you basically do it. You need to tell the person, well, I want to have, you know, n instances, this number of CPUs, RAM, and storage, right? So to build off, things shouldn't be too hard, should rather be easy, at least from a GUI perspective anyway. There's a few aspects that we need to be dealing with. One of them is images. So images are basically a pre-configured, images are pre-configured virtual machines, right? So it's basically which you can use, instantiate, and actually, yeah, use on your own behalf. So basically, some software may or may not be pre-installed with images, generally operating system level, because you guys don't want to be dealing with installing, you know, Ubuntu or Windows on a machine. You'd rather want to just spin it up and run your application of choice, right? And on the other hand, you have what is so-called flavors, and flavors are yeah, we're lucky. Flavors are basically basic configurations of machines. So the easiest way of showing that is probably just to launch an instance and see if I can move to flavor immediately. There you go. So you have different possible configurations. I talked about this before. It's quite relevant to remember that to some extent, because it's exactly the same Amazon Web Services, for example, right? So they also have flavors for machines, and some of them are part of a free tier, meaning you don't pay for using them, whereas some of them are on the advanced tier. Obviously, they're scaling up far larger in AWS than they do here, but this is basically the idea. So you need to know what is the kind of platform, you know, the hardware you want to be running on, and obviously the software you want to be running as well. So if we look if we look at the images section, so that's the software bit, basically, you find a set of pre-configured instances with particular operating systems, right? So we have, for example, Ubuntu Server in various flavors and variants. We have Windows 10 and Windows Server 2012 and 16, if that was of relevance. So meaning the whole concept here is entirely operating system independent, right? So similar to VirtualBox, you can run pretty much any operating system in here. So it also offers you the opportunity to actually try and test your application if it runs in different environments. If you think about automating the deployment across different flavors of Ubuntu or Ubuntu and Windows and so on, it provides you a good starting point for actually trying out software, right, in this kind of controlled environment, as opposed to doing it all manually by doing manual installs or running your own VirtualBox instances and so on. So it's a good way of thinking about how to automate many of those aspects. In addition of these ready-made images that are properly installed, so basically, yep.
I was wondering, what's the column with the protected? What's that?
Can you protect it?
Yeah, absolutely.
Protected generally means that it can't be, can only be managed by an administrator. So you want to have, for example, base images that nobody should touch, right? So, but you could also possibly allow their deletion by you know, other administrative users. So that's usually one way of protecting your base images. So I think that's the context here as well. And if you, in addition to that one, create images, so for example, that's the admin perspective, but from a user perspective, you can create images as well, but more likely you will be creating snapshots, meaning you use those images, build on top of them, install, let's say, a web server on it or Go on it or whatever else, and then you recreate a new image from it. And then on your side, you can decide in how far it should be visible to others, so you can potentially share it with your you know, peers or other members of your project, right? So things are organized by project, basically. So that's the, yeah. So we find, is there any unprotected SUSE leap is unprotected? So those will be, yeah, most likely the ones that are actually set up by the IT staff, the OpenStack managers down there, downstairs. And they just provide those images and probably update the introduce the most recent ones. We see Ubuntu Server 17.4 here, the 17.10 has just come out, so in a few days or weeks there may be possibly another variant, but I see it's just that is not protected, so it's probably maybe have been created by someone else. So yeah, so we have images here, but we also have snapshots here. Examples can be found up here. So those are the ones that I, for example, did, and they are basically snapshots. How they work is basically that they, instead of capturing the entire image in its entirety, the entire operating system, they just focus on the diff, right? So, yep, please.
Are there any documentation on how to log in?
Oh, yep. So I shall. Yes, it's on my slide set of last week. But also, you can just type skyhigh.hit.no, and it should redirect you to that very page here that you see. The domain will be NTNU.
And that was my question. The domain.
Ah, yeah. NTNU, and then your fader logins. So it's directly linked to that. Sorry, I thought it was implicit. Did everyone get that? How to log in? skyhigh.hic.no, right? So sorry, I treated that as implicit. Okay. So regarding snapshots, the way it works, and that's one of the efficiencies of those things. It's a bit like it's a bit like doing it in American Airlines. So, so the idea is you have a base image that, for example, has 4 gig, right? So, or whatever, I'm making stuff up here, it doesn't really matter. And now, all of you guys, for example, use that as a basis and create your own images, right? So, for example, this is Ubuntu, you install web service and Go, someone else installs only Go, someone else installs, I don't know, a database service or MongoDB or whatever else, right? So, and how the system works is basically that it just captures the diff between the original image and the modified image that you guys have instantiated, right? So, theoretically now, you should be occupying, so we created 3 instances, you guys should theoretically be occupying now 12 gigabyte of disk, for example, right? So we have one single image of 4 gigabyte, 3 instances of it. So 12 additional gigabyte have been created, right? Makes sense? Everyone on board? So, but how the system actually works is that it's really only checking the delta between those images. So what has actually changed on a block level, right? On your disk level, and only stores that one. So basically, the idea there is that instead of actually allocating 4 gigabyte of space for your particular instance, for example, it may only be 200 megabytes, right? Because those are the only changes that you have introduced compared to the base image. Yeah. So you have a delta, a difference in the blocks of, let's say, 200. This one has 150, and this one, oh yeah, no, it's only 50 because he only just ran up-get and nothing else really happens, right? So actually, the overhead is much significantly reduced, right? In this particular example, we would arrive at around 400 megabyte for all 3 instances, in addition to the 4 gigabyte for the base image. Yeah. So that's the idea, that you have a notion of thin provisioning. So you can easily over-provision space. So you can create far more instances than physically possible if you use those deltas, right? So even if you had a limited space, let's say of half a terabyte, you could well over-provision over 3 or 4 times that size, because it's very unlikely that you guys change the entire 4 gigabyte image, base image that you're building from, right? So you will always introduce incremental changes, but it's very, very unlikely that you actually exploit your 4 gigabytes. So that's one of the examples of virtualization, that you can largely, vastly over-provision whatever you actually have, and in terms of physical space. And that's quite similar to American Airlines, right? They did the same thing, so you guys recall that? No? So it was the same concept of over-provisioning. So they're counting on the fact that not everyone boards the airplane or comes to, flies with them anyway. So they basically sell more tickets than they have places on board, right? And most of the time it works out, because some people don't show up, so they can actually, shuffle people around and work with this over-provisioning. But if it doesn't work out, then you obviously run into capacity issues, and that was where we had the negative headlines, right? So you guys recall that when they pulled out some passengers out of the planes, and with considerable resistance and so on. But this, again, it's the same concept here. The difference here is only it's extreme, again, probabilistically very unlikely that you actually exploit the physical memory you have been allocated, but instead just use a subset of this. So, meaning the system that we're working on actually benefits from the fact that you guys are all working on the same image and using the same, the same baseline image, right? So that's the key benefit, as opposed to you going ahead and installing your own virtual box on a server provided by NTNU, and each of you doing the same thing. This way you would have total replication of the entire data set, right? It's like taking the entire copy. And here it's really just moderating or monitoring the differences between the base image and the change. Was that somewhat clear what I did here, what I talked about? Or is it totally unclear? No answer is no answer. But so what I want to get at here is, with this kind of system, you think, but now think enterprise, for example. You can actually produce considerable savings, right? Just by using that thin provisioning idea, and just have instances spawn up. Just keep track of the differences, and other than that, just use a base image. So you have considerable savings in terms of resources. And that's precisely how those snapshots work. So the snapshots, if I take them from a given instance, so I'm building my own instances of a given image, run that, do some stuff to it, configure it, set my environment variables and so on, and then I take a snapshot. And the system only takes the diff of that one and adds those here as snapshots. That's the key idea. Yeah. So that's why they're usually rather small, if non-negligibly small. Even though here it writes actually 0, the size of 0 bytes, which is doubtful. I think it's just kind of a bug in the implementation, because OpenStack is really still under heavy development. Yep, please.
How do you install software and stuff like that?
Yep. So we get to that. So I just wanted to give a bigger picture overview, because it seemed so to give you a bit more context. So before we get to that situation, so we also have volumes, right? So instances is basically the running environment that includes the image, and volumes is the counterpart from a hard drive perspective. So that's actually the physical, virtual physical storage that's attached to a particular instance, like your hard drive. And as in real life, you can attach one or more hard drives, right, or more volumes. Yeah, just to be comfortable with the term volume, because we will come across that later in Docker as well. Yeah, so it's the idea. Think about it like like hard drives is probably the best way to call it. But because in fact it's even mounted like this. If you look for this in this example here, I try to increase the font. Give me a second. See how successful I am. Yep, somewhat. Cool. So we have volume identifiers here, so it's global unique identifiers, not really helpful. We know the size, we know the status. So this one, for example, is currently in use. It is used by some instance, and it happens to be the Docker instance 1, and it's mounted on that location. So in the you recall the Linux file system hierarchy. It has a /dev subfolder, and this was basically devices, stands for devices. And this is where this this volume is mounted as VDA1. So it's one system volume that you can freely use. And the same for the other ones. So that's basically how it works. It says where it's available, so you can have various availability zones. So if you scale up your OpenStack instances, you can share volumes across multiple zones or manage them more hierarchical. In our case, it's very simple. We have one zone because it's more like a education environment only, just for testing, and if it breaks down, so not super critical. So we have limited availability zones. The question if it's bootable, it can also be encrypted. So this way you can control ownership of your volumes, even if it's hosted on AWS or with someone else. Yeah. So there's this security element that we always fear, because again, cloud just means you're running your stuff on someone else's computer, right? So it's always important to bear that in mind. Your control is very limited. Cool. So those are volumes. And now let's get to the instances. But just as a reminder, before we do that, again, we talked about this briefly before. We need to have configured security groups and key pairs. So what were security groups about? We talked about it quite a bit. Does anyone recall security groups? Please.
Is it
relieve me.
a set of rules?
Yeah, cool. On what level? What kind of rules?
About
Is it
security stuff, access, permissions.
Yep. That's why I'm asking specifically. So, is it like access rules? Is it constraining the user that's allowed to authenticate?
Isn't it access control lists?
That would, right. So, right. This one is, you said the term network was the kind of thing I'm looking for, right? So this security groups only manage networks rules, right? So it doesn't manage, for example, authorization or authentication against machines. So it doesn't restrict who is able to log in and so on, right? It just says which port can be accessed from the outside, or what is this machine allowed to do on the network. Yeah, so it's network centric. So security groups. And that's the same in all big solutions. So if they call it security groups, it generally only relates to network activity, right? That may change over time if they change their implementation, but generally that's the pattern. And we have rules that describe the direction of traffic, how it's constrained. Egress is outgoing. IPv6 is the IPv6 protocol. The underlying transport protocols, TCP and UDP, can be constrained. And the remote addresses you can address, contact can also be constrained. Those are the base kind of rules we're dealing with. This one here, just to clarify what's happening, the idea is that any outgoing IPv6 traffic is allowed. Any outgoing IPv4 traffic is allowed. Yeah, to anyone. This means it's open-ended, so pretty much like a wildcard. Any incoming ICMP traffic is allowed. What's ICMP again? Yeah?
Like ping.
Exactly, right? So ICMP is basically a ping protocol that we know, just a way of actually diagnosing connectivity. That's it. But again, it's a protocol you need to allow. If you don't allow it, you won't be able to ping your machine, you think it's offline. So for diagnostic purposes, it's often quite useful to have this kind of rule. Similar here. We allow incoming connections, TCP connection on port 22, which is SSH, right? Secure shell, that's what we need to connect to the machine in the first place. And we do the same for two other rules, 8080, and I'll just delete those ones for the sake of clarity. So let's stick with 8080. 8080 is oftentimes a rule that we need to test our web service. Most of the time when we run something locally, we usually run our REST web services on port 8080, right? So it's probably worthwhile to have that open as well. So this is like a base constraint. So we have the access and security via security groups. And the other thing I wanted to remind you of were the key pairs, right? So the SSH key pairs that need to be pre-generated or imported on the server side, because they will be injected into your particular machine instance as runtime. And then you can use that key to authenticate against the server, right? So it's the SSH concept of having asymmetric encryption with a public-private key pair. And you basically download the key pair and keep it locally so you can remotely connect to the other machine. That prevents you from specifying overly weak passwords. That's usually a risk, especially if you want to muck around, just play around. Your passwords will be rather weak. But the idea here is that the intent of machines that are hosted on OpenStack or AWS is that they're actually publicly available. They should have a public IP. And therefore, anyone could really, try out and to log in onto your machine. It's no longer just constrained to your own machine. Admittedly, OpenStack here is super contained, right? Super sandboxed. There's no way you can, without any fuss, access it publicly. You would at least need to have a user account with Fader to do that. Few exceptions, but other than that, you won't even get close to remote logging in, which makes it kind of a bit tedious, but on the other hand, it's very secure. So you have those keys. The neat part about those keys, once you have generated them, or one or two or so on, you can keep them and reuse them for different machines. Yeah, so it's kind of a good way of doing that. First, you set up your key, and once you've done that, you kind of need to keep a local, the private key local, and then just use it when you connect to actual server, right? So it's the key idea. And when we look at, so how you generate them is basically just that you say, I want to create a key pair, you give a name, and then it will allow you to, that is not a meaningful name, but I'll just generate it for the sake of it. And it then will just allow you to download the PEM file, which basically includes the private key, right? So, and this is a file you need to keep. You need to kind of safeguard and ideally protect, but at least you need to keep it handy, because I don't think you can re-download it again. You would need to regenerate a key. Please.
How do you tell the difference between machines if they all use the same private key? Isn't it better practice to always generate a unique private key locally on your machine and then upload the public key?
Yep. So so to answer the question, yes, absolutely. So if you're running a production machine, definitely individual keys for every machine. That's very right. Yes. So when you say upload to the machine, what do you mean?
There's also an option that you can import the key, a public key.
That's right.
Instead of generating the key online and transporting the key over the network. It should never be online. That's
right. No, I agree. I 100% agree with you. You're actually right. More than the transport, I think the critical thing is the fact that it's actually generated on the server itself, right? Because it's been generated by a third party. The transfer is probably fine because it's the HTTPS, so you'll be sweet, right? But I agree, for a production system, that's not an optimal solution. Ideally, you have a set of keys handy and upload them. The key thing, however, is that you need to import them into the EC2 or OpenStack environment, because you can't directly inject it into the machine, right? Because you won't get access to that machine. If that makes sense. So it needs to appear here somehow, whether you generate it on the server here right now or import it. But for the sake of what we're doing here, I would be fine if you create the key on the server and then download it. But yes, obviously, both options are available. Yeah.
How does this thing between one and many computers work?
Yes, I didn't answer that. So you mean the extending the question?
I mean, like, you don't have to install the same software on like 20 different computers if you need 20 different computers.
Right.
Possible to just install it somewhere and everything just like spreads out and creates new.
Yeah. Okay. So two things. One, to extend on the question, the previous question was there. The question was how to differentiate different machines. Let's answer that one first. How do we differentiate different machines if we have the same key? Anyone? What's the unique identifier we use, you know, for machines?
MAC address.
More the software side of it. MAC is like the hardware side of it. IP address, right? So, because yeah, technically you're right, but from an internet perspective, you hardly have access to MAC addresses. You generally interact via IP addresses, right? Plus, since it's all virtualized, IP address is the key mechanism to interact with. So as soon as we know the IP address, we can use any key to try to authenticate against any of our 20 instances. Yeah. So if they happen to have all the same key, would be fine. So there's no problem of ambiguity there, but there's a problem of security, as you pointed out. That's absolutely correct. So to come to the second question, the question was, how do you automate deployment of software on machines? Is that what you were thinking, right?
Yeah. So
Okay.
you don't have to redo this exact same
Yep.
procedure for all.
Cool. So what possible strategies are there? What do you guys think? So kind of an open question for everyone. Yeah. Okay.
Use like the same methodology like when you create software, that you create a prototype class, like an image prototype,
Yep.
and you just clone it.
Right. So it's the same idea of the snapshotting here, right? So you basically use a base image, you install the software, you press create snapshot, and then create 20 instances of it, right? So that's one thing.
Oh wait, you can like create the snapshot of absolutely everything.
Yep.
Okay.
So you take an instance, I can show you here. So let's take any of the instances, not that we'll be using them because they are largely just for mucking around on my part, but you mark them and then you generally get the option to just say, create snapshot, and you give it a name. Obviously more meaningful. I tend to have some sort of numeric index, often dates and a brief description of what's involved, but for the sake of that, I'm just creating a snapshot. So this takes a snapshot of the entire machine, including its running state right now, because the machine is actually running. Yeah. So you can that's really handy for you know, trying stuff out, as you can imagine, right? So you take a snapshot, do your stuff, doesn't work out, well, you roll back to the previous snapshot, right? So something that's a lot harder with your conventional machine, right? So I think Apple had Time Machine to deal with this, which was kind of convenience, but this one is even more convenient in a way that you can also instantiate a new machine from a snapshot, right? So you can work continue to work in your environment after snapshotting it, and then, for example, run another instance of the snapshot to compare, you know, runtime behavior of the application. For example, you find a bug and you want to figure out, hang on, was it actually in my previous snapshot already? So you create another instance, just run the software there and see if it was the same kind of behavior, right? So those would be possible avenues. So you suddenly are dissociated from the one-to-one association of machine and image, right? So you can have an arbitrary number of instances. Yep.
It's like sort of Git for machines.
That is very right. Yes. So it has Git elements in there. Yes, slightly, but not as explicit, right? So you don't have. My commenting is very limited here. So it's literally the image name. But you're right. Absolutely right. So if you see now here, you find under images now that there's this new 02 test and so on. It's basically just a snapshot. It does not explicit about this, but I could now instantiate it as a new machine, and it would, you know, be totally independent from the index instance it's coming from. Yeah, cool. So that would be one way. Was there any other comment? Cool. So I'm not. Yeah.
So would that image there have the SSH key?
That would include the SSH code. Everything. It's like literally taking that machine and setting up there, and it has everything. Yep.
Okay. Wouldn't that be a security vulnerability if you don't know exactly what sort of keys or passwords or what's stored in the environment?
Again, sorry. So what is in a vulnerability in which sense?
Like if it contains variables that you want to have secret.
Yeah. So the only way would be really to you know, remove all that stuff before you take the snapshot. Because the snapshot doesn't have any particular semantics other than taking a diff of your block structure on your virtual hard drive, from the image that it's based from, right? So it doesn't really look into semantics and looks, okay, what was the network configuration, what was other configurations, just takes blindly the entire offset and then stores this diff as a snapshot, and then you can use it or not. But any of those considerations, they're very right, would need to be considered explicitly. So it's not something as part that's handled out of the box. Cool, right. Is everyone somewhat clear what's happening, roughly? Yeah. Cool. So that's what OpenStack out of the box has to offer. Obviously, with many more options, different network types, and different zones and things we actually don't explore right now. You could also have different projects you'll be dealing with. Right now, for example, I have 3 different projects here, but we're working in one of them. So you can, if you think about a development environment, you could have one project for each customer or each client, for example, and have your development environment neatly grouped in there, things like this. But fundamentally, it's actually quite straightforward, and it's the same as Amazon EC2 fundamentally. So, but let's launch an instance. So, because we want to do something productive on that as well. So again, to launch an instance, you go into the instance area. The prerequisite is that you have created a network and a perhaps one word on networks. We had that before, but just to structure the discussion a bit more. So here we see the actual network structure, how it technically is in OpenStack, and that is specific to the installation here. But I want to highlight this so you guys know what's actually happening. So it's basically, get rid of this for now. 3 layers. So this being the the public internet, if you like, the publicly available resources. Then we have OpenStack sitting below this, and OpenStack has its own network. Which is called XNet. So it's actually linked to the, this is the own network. It usually has IPs, something like 172.2 and so on, 16.2 and so on. Those are managed globally across OpenStack. So any IP address that's assigned this way can access any other virtual machine in OpenStack, presuming, obviously, that the machines allow that. Remember the security groups? You could simply constrain access to everyone so no one can access your machine, that's fine. But in principle, you can communicate within OpenStack, right? So below that level, we have yet another network that you need to, unfortunately, configure yourself manually. And that's kind of the private network that's internal to your set of machines that you're dealing with. For example, you're creating 2 instances. In case you're creating 2 instances, you can communicate amongst those. It doesn't mean that anyone else can communicate with them. Yeah. So there's basically 3 layers of connectivity here, and obviously you have some link here, so you can actually get to the public internet. Yeah, if that makes sense. So this is the network you need to configure. It has one gateway that links you to the OpenStack network, and then fundamentally to the public internet. So to make your machines accessible to that network, internal OpenStack network, you will need to assign what's called a floating IP. Right. So floating IP is basically takes an IP out of this pool and assigns it to your particular machine. This way, suddenly your machine becomes accessible directly. Yeah. So that's something we will do all that together, so it will be clearer then. I just want to give a conceptual overview before we do it. So at this stage then, you can communicate throughout this network. So the only constraint is you still can't access your machine from the internet, right? And we actually can't. The main reason for that one is that there's simply not enough, that we simply don't own enough public IP addresses, right? So again, the IPv4 addresses are constrained, so we have limits there. And if you wanted one, you actually need to go down to IT and ask them, but they're very unlikely to give you one. So, so the only way for us to connect to our machines is to go into a host that is connected to OpenStack, and it happens to be skyhigh.iki.no. So the only entry point right now that we have is Skyhigh, right? So they call it a jump host, right? So you need to have an SSH connection to Skyhigh, And you do that using your username and password. So that's the first step. So your usual username and password. And from there on, you make a connection using the command ssh-i and then the name of your key. For example, dummy key.pem, right? Those PEM files we just downloaded. And then depending on your machine you're dealing with, for example, if it's an Ubuntu machine, like in most of our cases, it's Ubuntu at and then the floating IP. So, you know, some 172.16, blah, 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 blah. So, and this will actually bring you then finally into your machine, right? So it's 2 steps involved to get from the internet to your actual machine. So quite tedious. But that's part of the deal we need to be dealing with. I know there are other solutions, but we don't want to exploit that too much. On the other hand, I want you guys to understand what's involved traversing through those different networks layers. Is that somewhat clear what's happening here? Please note the tutorial for how to do that is also in the previous slide set. There was a set of instructions or commands that are listed there that you would need to run through to actually get to that stage. I can just bring them. I probably could bring them up just so you know what I'm referring to right now. Where is it? So, more detail, try it out. So there's a whole tutorial set up there as well, but I just want to show you the this one. So basically, it's a bit involved, but it's the one-timer. So the idea is you need to have, on Windows, for example, you would need to have PuTTY, which is like an SSH client. It's the same as the command SSH in Linux. And then WinSCP, which is the Windows variant of SCP in Linux command. And you would need to log into this jump host, so skyhigh.hippo.no, and copy the private PEM file. And I think that's where the corner over there will get nervous again, because suddenly your private key sits on the jump host, which is obviously not an optimal solution either. But you copy it there into your account, so you know you log in using your usual failure credentials to SkyHigh, and then you you need to set the permissions. To do that, you need to log in using again from SSH. You need to run the command chmod 600 private key file, for example, so name of the private key file, to ensure that only you can read and write from it. And then after that, you should be able to run the command ssh-i, using the private key file as parameter, and then the Ubuntu at IP address command. So, but this copying process only needs to be done once. Once it's on the jump host, you'll find you can just run the last command ssh-i. Yeah, but those are the involved aspects to get access to the machines. Okay, so so that seems to be a reasonable cut right now, I think. The idea is that well, what I do now, I just bring up one instance of a virtual machine, and then we take a break, because it's probably good to do it now because it takes a while. So we can just cut that short. Class instance. So I call it class instance just because we do it in the class. And we only create one. So again, that's the question as before, how can we scale up? Easy, you increase the number here, right? So you can create an arbitrary number of machines. So here's the question, what's the source of your instance? And you could say, well, it's actually a volume snapshot. Yeah. Recall that, again, we can take snapshots and we could use those ones as a baseline, or we could just use, so those are all the snapshots that are available, including the one I just created before. Or we want to have conventional images that we want to use. And those are the more conventional ones, for example, here. And again, I will use the AMD64 version of Ubuntu server. So here we have the image. Then the volume size, again, I would make it rather large. Let's make it 12 GB in this example. It's not really large, but be generous somewhat. Then we need to again pick the flavor. Recall the flavor is the hardware configuration that we want to use. For our example, we use something with 2 GB of RAM, which is probably reasonable. So I use this one here. We allocate this. We have a test network that has been set up. I'm not exploring that right now. Security groups. So which security group do you want to attach to it? We want to use SSH. So down here is the available security groups, and we only have 2 of them, SSH and default. But since we have created the SSH one previously, we can just use it now. So I also recommend you to create security groups beforehand and the key pairs as well. So it's very seamless when you instantiate a machine. So here, I'll take another key because that's the one I have already set up. Another key for that instance. And then you could have an post instantiation configuration options, which we're not using. So you could actually run some scripts after instantiation as well if you feel like it. Allocate to some groups and customize the execution characteristics of that machine by parameterizing the CPU, but we don't use any of that. We just stick to the standard environment and simply launch the instance. So that will now take time because it involves both allocating block device, meaning hard drive, the network interface, as well as obviously the setting up and configuring the whole image and recognizing the instance across OpenStack. So that will take now a while. So I probably suggest that we take a break for 10 minutes. So we probably could continue 1:20 and then we go from there and actually look into Docker from there. So get one abstraction level higher again. So from yeah.